Let's review a few exponent rules. So the first is we're multiplying two things that have the same base. However, exponents on them when you're multiplying, you want to keep the base and add those exponents together. When dividing, we want to keep our base again, which in this case is a, and instead of adding, subtract our exponents, giving us a to the fourth. When we have several things being multiplied inside a set of parentheses with an exponent, that exponent can be applied to each component within the parentheses. 3 to the fourth, x to the fourth, y to the fourth. And of course we can turn 3 to the fourth into 81. This rule is also applicable when it is division. So let's say we had 3 over x to the fourth power. Again, that fourth power, the exponent, can be applied to both the term in the numerator and in the denominator. The last rule is when raising an exponent to an exponent, we're going to want to multiply those exponents, giving us b to the third. This really is just an extension of the addition rule. As long as we break it down into the idea that squaring something means multiplying it by itself, b cubed times b cubed, we can see by applying the addition rule we would get b to the 6. So I did not multiply previously. 3 times 2 is in fact 6. Now, of course, the complications here come with some of the ways the problems are presented. There are also some common mistakes that people make, which we'll run through a few of, and also once you start combining all of these rules together, it can get a little trickier, but you're going to want to make sure that you're accurately applying these 3 rules within any context that you're working. So one common mistake is when bases are represented numerically instead of with variables, we can get mixed up with our exponent rules, and sometimes we might make the mistake of calling this x to the third. However, as we learned in rule number 1, in order to multiply two things, they should have a common base. That is, they should have a common base if we are trying to apply an exponent rule. And since 2 to the third power has an exponent on it, we need to be applying exponent rules. Now, if this had been written as 2 squared times 2 cubed instead of 4 times 2 cubed, then we have it in a form where we could use our exponent rules. That would be 2 to the 5th power. Or, of course, you could also follow order of operations in this particular context to do 4 times 8. In either case, you will get the correct answer of 32 and not the incorrect answer of 8 to the third. The next mistake we'll sometimes see is distributing exponents through a set of parentheses that have addition. And this is a misapplication of our multiplication rule. Since there is addition inside the set of parentheses, you are not allowed to apply that exponent to each term to get x cubed plus 8. This is not okay. Again, cubed means to multiply something by itself 3 times. And so if we were to write this out fully, we would realize that, well, in order to solve this, we should pick 2 of them and FOIL it out, and then we can multiply by the last one. When we get -3 squared, we'll always find that there are 2 different answers that students give, -9 and 9. And verbally discussed, both of these seem to have pretty good arguments. -3, when you multiply it by itself, does in fact equal 9. However, if you were to square the 3 first and then make it negative, you would get -9. So what's important here is that we understand our notation. And the number -3 is a shortcut way of writing the multiplication problem, -1 times 3. Because of that, if we write out our full problem, -1 times 3 squared, we see that because of order of operations, the squared should happen onto the 3 first, then we should multiply by -1, giving us the correct answer of -9. And the last one can sometimes be a mistake of an application of the first rule. We see addition there. We are used to this rule where we add exponents, and so if working through a problem that has a bunch of components to it, we might be inclined to call this x to the 6th. But this problem does not fall under any of our exponent rules. It instead follows our rules for combining like terms, in which case the base and the exponent must be the same for both terms. It is. Therefore, the way you combine them is by adding their coefficients. In this case, the coefficients of both terms is just 1. And so we would get 2x cubed for that problem. So now that we've reviewed these rules and kind of gone through a couple of mistakes that you want to try and avoid, take a look at the 8 problems that are given here, solve them on your own, and then take a look at the answers provided to the right of the video to make sure that you solved them correctly.